Hello dear friends. So this week we will look at outdoor air, how it acts to source of indoor air, and then some aspects, what is the exact process of this transfer, and some calculations as well. So in this particular lecture we will look at the introduction and look at one particular pathway, which is ventilation. So outdoor air, we will go over some introduction. See, the indoor air quality now results from a very complex dependence on many factors, as we have seen. Uh, so we have outdoor air, we have then ventilation rate. So how good is the exchange or the transport from out to in or in to out? Building tightness, then what kind of filtration is there to sort of remove maybe some pollutants, but we also have the situation with a mixture of pollutants coming in or out. Then of course the influence of occupant behavior also cannot be ruled out, and then we may also have some indoor emission sources themselves. So literature has more or less suggested that outdoor transport or outdoor air, transport of outdoor air can be a very important factor influencing the indoor air quality. We'll look at population level information, maybe not for individual, may not be the case for individual houses or individual rooms, but when we are looking at all the population and all the possible building environments and how important is outdoor for indoor air quality as a whole, outdoor transport of outdoor air to indoor seems to be an important factor influencing the indoor air quality. So overall outdoor air has an important role to play in the indoor air levels. So we will in this week try to identify or go over some sources of outdoor pollution which are actually quite common, so we will not spend too much of time on that. Then identify some pollutants for which outdoor air is relevant for indoor air. Then we will provide an overview of the process of infiltration as well as ventilation. Then assess the quantitative relationship between indoor air and outdoor air concentrations, because then we can see how important is in fact indoor air in influencing outdoor air influencing the indoor air quality. Then we will also assess some air exchange or ventilation factors. So what is the rate of change of air or how much air is being flushed that can lead to contamination of indoor air with outdoor air. So some of the common outdoor air pollution sources are to influence indoor air are also the sources which influence outdoor air also. So here we have traffic, basically proximity of busy roads in terms of cars and trucks which are fueled by petrol or diesel, cars, trucks, also two-wheelers, motorcycles, scooters. If the house or the building is situated close to these traffic sources with a lot of buses and two-wheelers and four-wheelers going around, then naturally if the outdoor air comes in, there will be a impact on the indoor air quality. If the houses are close to industries, so these could be power plants, industrial plants, manufacturing units, and if they emit substances to air, the people who are living nearby, it is quite natural that the outdoor air will manage to come indoor air, and since these houses are situated close to the sources, even if there is a small amount of outdoor air coming, maybe the concentration, the pollution load itself is high, so that the indoor air becomes reasonably contaminated. In current scenario, in current settings in India, construction sites are also could be important sources. Whenever there is infrastructural activity, construction activity, there is a lot of construction debris around, and if the control is there, but if it leads to overall increase of pollutants, dust load in the outdoor air, if a house or a room is close to that, then we will have influence on the indoor air quality again. Then we have the waste deposition or waste disposal sites. So here you can have dust and also as well as volatile organic carbons and any other kinds of fumes, because then they will also be transported with air and go to the indoor environment. Then again, various kinds of agricultural activities. So as we have seen in the previous lectures, when we are looking at sort of people spraying insecticides or pesticides on the garden, and then a person may walk in, so the person will bring the dust which contains these chemicals, or if they volatilize, then through windows these compounds will come inside the room. So various kinds of industrial activity, agricultural activities, for example spraying of pesticides, may also lead to indoor air quality issues. Generally, vehicular combustion contributes several gases, and some I have listed here: carbon monoxide, and then hydrocarbons, volatile organic compounds, and other compounds, and oxides of nitrogen. These are quite commonly emitted. Then these are the compounds which may be important when we are looking at vehicular combustion. When we are looking at combustion from stationary sources, industrial plants and processes, often they may lead to the emission of oxides of sulfur, in addition to several other compounds that are noted here, and even heavy metals. As a general, we are highlighting here sulfur, but also a big suite of contaminants are being emitted. So same thing, industrial processes can also be a source of volatile organic compounds, and also actually heavy metals and particulate matter. So once we sort of sum this all up, the major contaminants emitted by these sources are carbon monoxide, oxides of sulfur, oxides of nitrogen, then a lot of volatile organic compounds, polycyclic aromatic hydrocompounds, semi-volatiles may be formed later, so we will have also secondary organic aerosols being formed, and then of course particulate matter or particles. So again, a number of sources, and most of these sources are also common for the outdoor air quality. So that and that kind of leads into this argument as well, that the indoor air quality is actually influenced by the outdoor air quality, because all these pollutants influence outdoor air quality, and when this air comes inside, then we are also having an influence on the indoor air quality. So studies have of course shown this as well, that indoor air quality is indeed affected by the outdoor air. So it has been found, for example, during a dust storm event, people have found similar increases in concentrations of PM 2.5 in both indoor and outdoor. So a dust storm event is essentially changing the air quality of outdoor air, but it has been observed that simultaneously there is a similar increase in the indoor air PM 2.5 and PM 10 concentrations. Now, it does not necessarily mean that if there is a 10% or 10 times increase in outdoor air PM, there will be a 10 times increase. Maybe it will be 5 times, 6 times, but the trend will be the same. So, sort of the indoor air PM concentration is following the outdoor air PM concentration. Generally, it has also been said that indoor and outdoor environments could both VOCs in both indoor and outdoor environments could be derived from outdoor sources, especially in the settings where there are less sources of VOCs for indoor air. For example, we are not talking about a garage or bathroom where we are storing chemicals, because there we may have more VOCs emissions from the indoor sources as well. A furniture which has probably old will also emit less VOCs from the furniture itself, and that particular room which contains the furniture will be influenced more by outdoor. But if it's a new furniture or a new painting, a new coating on the furniture or a wall, then probably indoor will dominate the outdoor. There are a couple of pathways of transfer of outdoor air pollutants to the indoor environment or indoor air, so to speak. So there are two main mechanisms that allow outdoor air to enter and affect the indoor environment or indoor air. One is infiltration, one is ventilation. Sometimes people may use these terms interchangeably, use ventilation completely or infiltration, but it is important to just keep in mind what they are talking about or what you are talking about. So here we have defined two processes, and we will look at them: infiltration and then ventilation. Infiltration is basically coming without any influence, and ventilation is where we are actually providing a ventilation, which can be natural, mechanical, or a combination of both. And once the pollutant enters indoor, it can either be diluted because the indoor is cleaner, or accumulated according to the ventilation condition. What is infiltration? Infiltration can occur by passing of outdoor air to indoor air through cracks and leaks. So this is the important part, through cracks and leaks in the bending envelope. So it is a significant process for buildings which have poor sealing. Maybe there is natural cracks in the building, or it's not completely airtight. So there is more chance of just infiltration of pollution in those. So in this case, even without the ventilation being provided, there will be a air exchange between outdoor and indoor air. So even without ventilation, air exchange between indoor and outdoor environments can occur. And this can be through natural processes or gravimetric, so sort of size density based ventilation. Here we have an example figure on how the air can actually come in. So this is sort of a schematic of a house or a portion of a house. Now there are some like cracks in the building, or there is some sort of possibility. Here this is the building wall which has the cracks, and here we have the building door. So naturally there is always door never makes the opening airtight, right? Or most of the time it is not completely airtight for sure. So through these small openings under the door, this is a part, and the door is closed. But through this crack, some air will come and infiltrate through, in this case, coming from here. And through the small opening at the between the bottom of the door and the floor, there is some small opening. So then again there will be some transport. So this is what we are terming here as infiltration. Okay, now whereas if you are providing a mechanical fan, or in this case we have a window AC, so the air is coming in and is pushed inside. So AC or fan, a window fan basically. So these are mechanically pulling the air and putting them inside. So outdoor pollution is being entered through mechanical ventilation. Of course, you can put filters in this area to remove the outdoor some of the outdoor pollutants, but the thing is this is mechanical ventilation. Then we may have a window. So in window we are not putting a fan, just window is opening, so it's basically a natural ventilation route. So here the outdoor pollutant can enter through a process of natural ventilation. And of course when we are looking at the sources, all the sources we have to take it complete that there are indoor sources as well. But hopefully in this figure we know now what is sort of called infiltration and what is called mechanical or natural ventilation. So now we will go a little bit on ventilation. Ventilation or air exchange plays an important role in the process of introducing air pollutants indoors, as we have seen in the previous figure. It can also determine the dilution of pollutants depending on the conditions. So why is it actually necessary? It is necessary in occupied indoor spaces to often remove indoor generated pollutants, because if we are saying it's only bringing outdoor air to indoor air and that to pollutants, then that's not good. But it may not always be the case. It may actually bring cleaner air also. So ventilation helps to remove indoor generated pollutants. It can also remove humidity generated by the occupants, because we breathe out some, the air is much more humid than the ambient air. So it removes the humidity also. And also ventilation means air is flowing it. So in general our comfort level also increases if we have some cool breeze or nice air flowing in the room. We may feel much more refreshed. So to remove indoor generated pollutants, to remove the humidity generated by the occupants indoors, and the comfort of the occupants indoors, ventilation is important. Now it has some basic elements, the ventilation of a building. One is the ventilation rate itself. which is the amount of outdoor air that is provided into the space, and of course the quality of the outdoor air. So how much air is coming and what is the quality of the outdoor air. If it's a good air, then good. The more the outdoor air comes, the more indoor air will become cleaner. So amount of outdoor air and also the quality of air. Then airflow direction. The overall airflow direction in a building, which should be from clean zones to dirty zones. So basically, the clean air is flushing out the dirty air. That's the meaning of this sentence, and not the dirty air is being pushed through and replacing the clean air. It should be cleaner air pushing through the dirty air. So push dirty air out and replace it with clean air. Then another thing is the air distribution or the airflow pattern within the room or the indoor environment itself. So in this case, the external air should be delivered to each part of the space in an efficient manner, because there may be some stagnant zones in the room, which means those zones will not be flushed. So the external flushing air should be delivered to sort of each part of the indoor air in a very good manner, so that the airborne pollutants generated or existing in each part of the space are removed in efficient manner. So if there are no sort of stagnant zones, the flushing is being done of all the zones, so any accumulation or generated indoor air pollutant should be, any accumulated or generated indoor air pollutant can be flushed out. So the distribution of air and the pattern of air within the room also is an important component. Now we will look at these different processes of ventilation. The first is the natural ventilation. So as we have seen in the figure, and then we will also look at them a bit more here. So we have doors and windows, which are very common. Then we have wind towers and technical ventilators, which also provide natural ventilation. And then we will look a little bit at the solar chimneys and the courtyards here. So first, natural ventilation, it can be driven by the prevailing wind flow. For example, when doors and windows are open. So just an illustration of a window. So in this case, we have several options. One is if there is a air coming from one window and then air going from another window, maybe a little bit ahead. So we have cross ventilation here. Of course, the window can be a bit down also, but this is a cross ventilation, which is air coming from one direction, crossing the whole room and going out of the room. Then we have single-sided ventilation, in which case air is coming from the same window and going out from the same window. Maybe here you have a fan, so natural air comes in and it's basically mixed in the room because of the mechanical effect of the fan, and then some of it also goes out. So same. Then we have stack ventilation. So in this case, we have the rubber regular window, and also we have openings in the roof and on the wall on another side. So here the cleaner air is coming in and is flushing out the indoor air through the top part, so sort of a stack, and also through this part, and it's going up. So we have three ventilations now: cross ventilation, air coming crossing the room; single sided ventilation, air coming and going out from the same side. Maybe there's another window, so coming in and out from the same side. Then we have stack ventilation, air coming in, going up or sideways. The next thing is solar chimneys. This is a very interesting concept. So this is our house. The bottom of the house, there is an opening, and this is the solar chimney. Now we have, let's say, some cool air is here, or existing air is already there, and then the sunlight heats up the cool air in the chimney. So when this air is heated up, this air will rise. So hot air rises out of the chimney, drawing more cool air. So as the hot air rises, now all this air is moving up. This air is moving up. So some of the air should come up to make up the air. We cannot have a vacuum. So as the hot air is rising, more cool air is coming from outside to inside. So as the heat is drawn up, cool air is drawn into the house through the windows and vents. So cool air is coming in to the bottom of the chimney and then rising, because here the sunlight is heating up the cool air. So we have sort of a naturally induced flow of air. Hot air rising, cool air coming in to replace this hotter air. So this is a sort of a solar chimney. Then we have a very important thing also in the Indian context, natural ventilation. Here is an example of a courtyard. Here the airflow is driven by the thermal buoyancy forces due to the outdoor and indoor air density differences, which may be due to the differential heating of air between outdoors and indoors. An example being the courtyards. So here there is an example. So this is during daytime when we have uh, sort of the buildings or the rooms surrounding a courtyard. So we are looking at the front, how the room looks like from the front, how the house looks like from the front, excuse me. So we have room here where there are windows and doors leading to the courtyard. So same thing as the chimney, the sun is heating up and the hot air is rising. So it sort of is drawing in the cooler air from outside. So in this case again the air is lifting and the outdoor air is coming in to make up this air. So some more cooler air is coming in to replace this air, or at least we are having a sort of a wind flow induced just because of the arrangement of the building. So it is sort of a no electricity requiring ventilation method, natural. In the night time, this there may be, like, you know, when there is cooling happening, some heat is radiated to the sea from the surface of the roof, let's say. So the cool air comes and sinks down, and this cool air comes in, and maybe this is a bit warmer, but this cool air comes in and replaces, and then the ventilation may occur in the opposite way. But the end result is that the air inside, here as well as here, in both the conditions, the air is a bit cooler indoors compared to the outdoors. So and we are also flushing the pollutants away which have been generated in the indoor environment, which was actually our goal, indoor air pollution. So all these pollutants, in this case they are being flushed in this direction, in this case they are flushed in this direction. Now in terms of heating and cooling, maybe some more modifications can be made. So here there is another sort of schematics where here we have a solid building, so its protection of hot and dusty wind from one side. Then in this place we have the courtyard, but with some water pool or water collection, and there is some protection of this area from the shade naturally, especially in this case. Of course the sun moves and there will be differential heating. We are showing the case where there is some protection, so reduced heat admission. Now the water is sort of evaporating, so we have a cooling by evaporation. So this air is a bit cooler now, and then it basically this surface cools down and the cool air is drawn through the rooms outside. So then this is another method of sort of reducing the temperature as well as ensuring the ventilation. So in general, natural ventilation of buildings depends on the climate. So of course climate should be such that natural ventilation actually helps in the movement of airflows. Then the building design, as we see, natural ventilation has no mechanical components, so the whole thing depends on the design and the location of openings, which will influence the transport of air. Then also the human behavior. If the ventilation relies on window or door and the person always keeps them closed, then of course there is no ventilation. So this is an example how human behavior itself can impact in ventilation of indoor air naturally. In general, natural ventilation has often been shown to maintain pollutant accumulation below the standards governing indoor air quality. So natural ventilation has indeed been shown to help in improving the indoor air quality, but it is also subject to variability, because as we see here, the extent of ventilation and its effectiveness depends on the climate, the building design and the human behavior. So these things should go hand in hand to the provisions made for natural ventilations, and it is quite possible that if outdoor air is cleaner, natural ventilation will actually reduce the pollutant burden. The next thing we will look at is mechanical ventilation, which is basically a sort of a forced ventilation. This is the ventilation, for example, provided by a fan directly on a window or wall. So the fan is running and pushing it air. It's basically the opposite of an exhaust fan. Or we have air ducts for inflow or act as exhaust. So same thing, they can bring it air this way or bring it air that way, but the thing is there is an exhaust or a fan there which is sort of driving the ventilation. Now since ventilation is controlled, we can have more or less, and mechanical ventilation has been shown to result in lower levels of indoor pollution because it's you can drive as much as possible this ventilation. It also provides tight controls of pollutant levels because it's dependent on conditions that we can control. So in general, mechanical has advantages as well as disadvantages. The advantages that mechanical ventilation can work as per the design regardless of the ambient conditions, or for example, it is not that dependent on how indoor and outdoor air is, and that will govern how much is the airflow. With a mechanical fan, we can always keep the fan speed relatively in a range, so we know that the amount of flow is more or less whatever it is as per the design. One can also attach filtration systems. So these can be used to remove dust, odors and microbes. So air is being pushed and we attach some sort of filter. So the air is pushed, and even if the outside is contaminated, the air that is coming in has less of those pollutants. So we can attach filtration systems. One can also control the airflow part depending on how we are locating our mechanical ventilators or fans or exhaust. We can make sure that there is no stagnant zone, and the airflow path is also like clean to dirty. It can essentially work in any place where there is electricity because we need to provide power, for example, to a fan. So same way, the disadvantage is because it depends on electricity, we should not have interruptions, or it is dependent on interruptions to electricity. Also maintenance issue, because if the fan breaks down, you have to replace or repair the repair the fan. So for that particular time, this ventilation system will not work. Sometimes installation and mechanical costs could be high. Installation could be your capital cost of purchasing and then having someone install it, and then depending on the extent to which mechanical ventilation has to be provided, the cost could be high. And also same way, depending on the operation conditions, maybe one needs to maintain them or repair them or service them frequently. So the maintenance cost could also be high. Now, in contrast, in natural systems, a natural ventilation mechanism, we can have a high ventilation rate generated economically because maybe our openings are large, and if we have designed it suitably, we have a large opening and air is flowing, so we are achieving a high ventilation rate without any cost. It can be energy efficient because we are not requiring any electricity. It is providing cooling or ventilation without consumption of electricity. Then maintenance costs are also low because all you need is openings. So openings are openings, they are not going to close down. So the maintenance costs are also quite low. The disadvantage is that since we are not able to control the airflow rate, the natural ventilation extent is variable and depends on the outdoor conditions relative to the indoor conditions, and that will drive the flow of air. As a consequence, airflow will be difficult to control. Sometimes it's faster, sometimes it's low, sometimes there may be no airflow, and I think these are the things that we already experience. If we have windows or a courtyard, sometimes you have a very nice breeze flowing, sometimes nothing is flowing or very little. It may not be possible to install filter because once you install filter, we are sort of providing an obstruction to the flow. So the flow rate will reduce. In mechanical it was okay because anyways the pump the fan will move and it will push the air. In natural ventilation it's a natural barrier, so the airflow will reduce. So filter installation is a bit tricky. So if we were to compare, make some small comparison on natural versus indoor, in general natural ventilation uh, rate was shown to be correlated for the concentrations of a total VOCs measures. It was negative, so in this case, the more the ventilation, the less VOCs were indoors. And in in this case, a particular study, there was no relation to mechanical, but that depends on the conditions of the environment itself. Indoor to outdoor ratios we will look more in the next few lectures. They were quite good for natural ventilation. Um, okay, natural ventilation does help, but mechanical ventilation may itself also be useful. Sometimes one may work, sometimes the other may work. So in summary, we have covered here that indoor and outdoor air are often very closely related, and the link between outdoor and indoor could be infiltration, and the link could also be ventilation. And both natural and mechanical ventilations are possible, and in general they also help. Infiltration and ventilation, if the outdoor air is cleaner, they will generally help lower the indoor air quality. So this concludes this particular lecture. In the next lecture, we will look at more of these things and a little bit on the health as well.